Hello everyone, welcome back. So today we're going to be talking about different air conditioning processes. Now, these aren't rocket science here, it's just four basic ones. You can heat your house, you can cool it, you can humidify it, and you can dehumidify it. So you're either adding heat, removing it, adding water, or removing water. And that's all well and great, and you're like, that seems super simple. And in some ways it is, in some ways it is not. So let's look at this chart right here. As note, this is I pressed a different button this time. Interesting. This is just like a little view of my psychometric chart before. Okay, my psychometric chart, which we went over a couple videos before. So if I just cool, I'm going to move to the left. If I just heat, I'm going to move to the right. That's just increasing my temperature. That's the lines they're going up and down, or decreasing it. Now, when I do that, we're going to find out through future slides, is that even though I'm heating or cooling, I'm not changing the amount of water that's in the air. The amount of water in the air is staying constant for this entire time. And so your specific humidity, not your relative humidity, your specific humidity is staying constant. The issue is that your relative humidity is changing. So as I cool, what I'm going to begin to feel if I don't dehumidify is that the air starts feeling really wet. Why? Because the relative humidity is increasing. It's getting to the point where eventually it's just going to precipitate out. If I heat without adding any water to the air, I'm going to suddenly start feeling, man, this air feels really dry, which usually happens in the winter. You turn on your AC or turn on the heat for the first time, and suddenly everything feels dry in your house. Why? Maybe because you're not adding any moisture. You might need to have a humidifier in there to add a little bit of the water back into it because the relative humidity is dropping. Your body really doesn't feel specific humidity as much as it feels relative humidity, because relative humidity is determining how much moisture is evaporating from your skin, because the less water that's in the air, and the more water it wants in the air, the quicker it takes it from your skin. That's why places like Arizona, they're great. You don't really feel the humidity at all because it has no humidity. It's just taking the water from your skin very quickly. Okay, so if I need to, keep it comfortable, I'm probably gonna have to combine these processes. I'll heat it and humidify it, or I'll cool it and dehumidify it, usually in combo right there. And I'll move me along these lines, either up or down. It doesn't have to be perfectly at a 45-degree angle. They just drew that for the picture. Okay, so basic equations here. We'll be using these to solve some problems a bit later on. There's nothing too crazy. This is just conservation of mass and conservation of energy, and we're just taking a few extra steps here. So first off, how much air is flowing into my air conditioning system and out of it? Well, it doesn't change. We don't add extra air typically. So the air is just constant. What goes in is what comes out. How about for water? Well, the amount of water that's flowing in and out of my system is going to be a constant as well. However, that doesn't mean that the water that's flowing in from the air is all that there is. I can, if I want to, spray water into the air. It's not necessarily how we do humidifying, but you can to add more water, and so that would be part of my mass balance. If I don't have any of that, though, the amount of water is determined simply by the amount of air that I have. The more mass flow rate of air multiplied by its specific humidity gives me the amount of water that's currently in the air. Okay, down the bottom, nothing too crazy here. What's the enthalpy of my air going in and out? And do I have any heat losses or inputs? Am I heating it? There's heat in. Is it losing heat because of, or is it being cooled? That's heat out. And then the work in is going to be due from my fan work input. I have something that's moving the air. Typically that's fairly small compared to everything else in the equation, but we'll sometimes use it. Okay, so let's look at a few of these cases. First off, simple heating and cooling. And like I said before, when I'm just doing heating or cooling, that's moving left to right, like right here. My specific humidity, that's this guy, that's the absolute amount of air I have per, per volume. Sorry, air I have, goodness. Amount of water I have per kilogram of air. It's a constant, okay? It's a constant, it doesn't change. So, if you have a house, it might be heated by various things. In my house, we have a wood-burning stove. We also have a heat pump. We don't have it, well, and for cold nights, my wife and I have an electric resistance heater for our bed. We use them all. Woo! Didn't realize I would have all those. And so all three of those do not add humidity. All they're doing is adding heat to the air. And so what's happening? Well, the air in the system, either the stove, the heat pump, or the electric resistance heater, it's just air flowing through and having heat pumped into it because that's being generated by burning wood or by burning oil or by pulling heat from the outside or through the electrical resistance. So when I do that, the amount of water in the air, the absolute amount of water in the air, is staying constant. However, the relative humidity is actually changing. So look right here. I start off in this, heating process, or sorry, cooling process, my bad, going. It bothers me that it shows heating coils and it gives an example for, you know what? I'm just gonna redraw this arrow. I don't like what they're doing here. Okay, there we go. It's a heating picture. Why is it showing a cooling example? So with that, I'm heating it. I'm going from 12 degrees Celsius to 30 degrees Celsius. In this diagram, you see I'm not adding any moisture. There's no water pumping in here. I don't have some spray nozzle. I don't have water that's evaporating. It's just air flowing through it. Whatever water it had at the beginning is the water it has at the end. And so its specific humidity is staying constant. However, what you can see here is that its relative humidity is dropping. It goes from 80% to 30%. So at that point, you would probably begin to start noticing that it felt dry in your home. If it got lower than that, you would begin to notice that more quickly. And you might have chapped hands, chapped lips. It just doesn't feel nice. And so what do? Well, you can add some humidity to it. Other things here. If you're trying to figure out how much heat you have to add to get this change in temperature, well, it's simply equal to the mass flow rate of your air. The faster you go, the faster you have to add the heat. And also the change in enthalpy. So for air, it's an ideal gas. I could just do Cp delta T here. So change in temperature, specific heat, and my mass flow rate. So those are all ways I could calculate that. Okay, now this time we're going to heat it, but we're also going to humidify it. Notice this shows like a two-step process. I heat and then I humidify. And so that's why we have this line going like this. This time the arrow is in the proper direction. I like this. This is good. So earlier I said, it's going to start feeling pretty dry. And you feel relative humidity. And so if I want to avoid my skin feeling too dry, getting chapped lips, getting cracked hands, then what I do is I add some water to the air. I add some water to the air to increase its relative humidity back up to a comfortable level. And so this is what we see right here. I have my heating coils. That changes the temperature. I have my humidifier. That changes my relative humidity. So then the question is, well, how much water do I have to add using my humidifier? So this is where it's a little bit more difficult, even though it's all connected. The amount of water you add is based on the specific, not relative humidity. Relative humidity tells me, am I comfortable? Specific humidity tells me, well, how much water is actually making me feel comfortable? And so I would actually have to know the change in my specific humidity that I want for that specific, for that relative humidity that I'm aiming for. And remember, early on we showed that these two are connected, so if I know one, I can find the other. I can go back and forth. It's okay. It's not terribly difficult. So with that, I think the next slide is an example problem. It is. So we'll stop here for now, and we'll go through a fairly detailed example problem dealing with heating and humidification. So thanks for listening. I hope this helps you. See you all next time. Bye-bye.